15.6, ethene reacts with halogens, so they symbolize that by an X right here because the halogen in this case is chlorine, bromine, or iodine, by the following reaction. And so here's the ethene, and then this is the halogen, and then this is what it makes, a halogenated alkane right here. The following figures represent the concentrations at equilibrium at the same temperature when X is chlorine here, bromine here, and iodine down here. List the equilibria from the smallest to the largest for the equilibrium constant. So the equilibrium constant expression would be products, so C2H4X2, divided by the reactants, which would be C2H4 times the X2, and of course the X would be dependent on whether it's chlorine, bromine, or iodine. And so now we need to count each of these molecules right here, put them into the expression for A, for B, and for C, and then we could know the equilibrium constant value K for each one of these. And then of course the one with the largest K would have the most products because the number on the top would be the largest. And the equilibrium constant would of course be the largest as well. So counting these up over here, let's see, I get a total of 8 of the C2H4s right here, C2H4X2s right here, these guys, 8 of those guys. So 8 would go on the top. And then C2H4s are the black ones with 4 hydrogens on there, 4 white little guys. And then there's 2 chlorines in there. Those are just the 2 spheres like that. So 8 divided by 4 gives us 2 for letter A. Then in letter B, we have 6 of these fully halogenated alkanes. And then we have 4 bromines in there and 4 of the 4 of the alkenes in there, the ethenes. So 6 divided by 16 gives us 0.4 for letter B. And then in letter C for the iodines, we end up with 1, 2, 3 of those on the top. And then we end up with 7 iodines on the bottom right here. There's 7 of these purple, just purple sphere guys right here. And there are 7 of the C2H4s in there as well. So 3 divided by 49 gives us approximately 0.0612. And so we can list them in order from smallest to littlest equilibrium constant. The smallest would be C. The next smallest would be B, and the largest would be A.